Okay, let's give problem 5 where you have to actually write the equation and figure out the percent yield a try. So the first part of the question says I've got solid calcium is burned in the presence of oxygen. So the formula for calcium is just Ca. And it is burned in the presence of oxygen, that's plus O2. The reason it's O2 is because oxygen is diatomic, which means it does not travel alone when you just see it alone. And it's producing solid calcium oxide. So that's producing solid calcium oxide. So to write a formula, I have to know the symbol and the charge. So Ca has a +2 charge, and O has a -2 charge. I get that because of the relationships of where these are on the periodic table. Ca is here in column 2, and O is 2 away, and so that makes it a -2. This is a +2 on this side, and oxygen has a -2 charge. So that means that I have these things in a 1-to-1 ratio. I basically say, well, the 2's cancel out because they're both 2's, and the formula would be then CaO. Then I have to balance this equation. So I've got 1 Ca, I've got 1 Ca. I've got 2 O's, but I only have 1 O. So I put a big fat coefficient of a 2 in front of the Ca. And now I have 2 Ca's, so I put a big coefficient of a 2 in front of the Ca. So this problem balances with a 2, 1, 2, because when you don't have a coefficient, those are the places that you can have coefficients, it's a number 1. So that kind of looks like a 10, so that's a number 1, and that's oxygen. Okay. All right. So now we have to do our stoichiometry problem. So to start out with, on our stoichiometry problem, we are going to write our template out, what we know. So the first thing that we know is we know the balanced equation, and we know that the given number in the problem is a 56.8 grams of calcium. Okay, as the problem says so here. It says if you have been given 56.8 grams of calcium, how many moles of calcium can be produced? So the first thing is I know that the given number is 56.8 grams of calcium. Okay, and my template looks like this, with the number over here of moles of calcium oxide is what I'm trying to solve for, because that's what it says. How many moles of calcium oxide can be produced? So here's my beginning template. If you have been given grams, what number goes in your template? If you've been given grams, molar mass goes in your template. Where did I get the molar mass of Ca? I just looked it up on the periodic table. So that number that you can't read, that hopefully you can read on your own, is 40. So the red number above the Ca, that's 40. So that's where I'm getting this 40 grams. Okay. This is the coefficient of what I'm trying to find. So what was I trying to find? Moles of CaO. What's the coefficient? It's a number 2. Then this is the coefficient of what I was given. What's the coefficient on the Ca? That also is a number 2. This is the units I'm trying to solve it in. What units am I trying to solve it in? Moles. I'm trying to solve it in moles because the problem says how many moles of calcium oxide can be produced. So that magic number for moles is the number 1. Now, when you have a number 2 over top of a number 2, or technically any number that would be able to be reduced, you can reduce that. So 2 over 2 is 1, so those would cancel out. And my ending up problem that I have to put in my calculator is only the 56.8 divided by the 40, because that's a 1 and that's a 1, so mathematically that doesn't matter. And so 56.8 divided by 40 is 1.42 moles. So I could make 1.42 moles theoretically, mathematically speaking. That's what they mean when they say theoretical. So it asks me in this problem to figure out what is the percent yield of the reaction if 1.38 moles of calcium is the actual. So 1.38 moles is the actual, divided by the 1.42 theoretical, times 100 means we were 97% on our percent yield. So that's how you do a problem, that you have to first write the equation, balance the equation, figure out your theoretical yield, and then plug it in to figure out your percent yield.